Hello there! In this episode, we're going to be discussing all the pipes that go under the slab, radon and plumbing. So I'm excited, I'm the official plumber for the project, and we will need to pass inspection for this episode, so let's get into it.
So we showed up to work like any other Saturday to work on the sub-slab plumbing, and guess what we found out? That's right, our excavator brought the excavator, so things are about to pick up, and we're going to be making some significant progress now. We've begun some work, and one of the things we requested was to add additional crush rock on top of the French drains. And in addition to that, they've been adding a geotextile fabric on top of it as well. So, but the key thing here is, see that excavator back there? It took a couple scoops. 2 scoops is the amount of effort that took me to do in 3 hours with a wheelbarrow. So if you can, it is worth getting an excavator for your work.
So we connected all the pipes, they are good and they are going out to the French drain, and that's it. Tomorrow we're going to fill with gravel. So we're doing a change to our radon system, and that's because of a lesson learned. Turns out that once you lay down pipe, you can no longer put soil on top of it. So what would that mean is that all this area we would have to fill with gravel up to this ledge level. So what we're planning to do instead is to cut the pipe around here, which is where the plumbing of the house ends. So the pink flag indicates plumbing coming here. So this needs to stay low. But from here to there, we're going to cut. We're going to bring this up to this level, use a fitting that's going to cost maybe $3 to $4, instead of having to pay for gravel, which is about $600 per truck. And we no longer have to use a ton of gravel there, which is going to save us a ton of money, literally. So while our excavator is working in the background, you may be able to hear him. We are finalizing the sleeves that need to go from the mechanical room on one of the houses to the other house. So we have 4-inch pipe, we're going to measure and we're going to cut it and add fittings to make sure we have the right length. So our excavator has begun work. He filled all the way to this sleeve level. So we have now laid the sleeves, connected them. They go from house to house. And remember that 14-foot wall we had and the hole below? It's about halfway there. So with this in place, now our excavator can continue working. So I think this is the first time you see us working on our mechanical room. So what we have right here is our emergency drain. It starts at about 1/3 from the wall, and then it comes all the way down, steps towards the wall, and then goes out. We decided to make the jump down, well, the slope down towards the wall, because if we ever need to repair this pipe, we want it to be as close as possible to the surface. And this may also make things easier for the excavator. One important thing we did is we marked the pipe with green paint, because we're also using perforated pipe for the radon, and we don't want to pick the wrong pipe by mistake. The other thing we have going on is the radon and the plumbing. So for the layout, the first thing we did was mark the plumbing from the house, which is going this way, and we mark a green line that way, so we have enough space for that pipe. And then we began laying out the circuit for the radon. Remember, the radon is going to be a circuit that goes this way, and then on that wall we're going to have a vertical pipe that's going to go up to the fan for the radon. So we are ready for inspection 4 out of 5 with Boulder County for our septic system. So just to recap, the first one was when we were digging snow out of the pits so they can check the type of soil that we have. Second one was the open hole. The third one was the system installed. And the fourth one is the connection from the house to the septic system. The fifth one requires power, so that one is still a few months out. So what we have here is like the final frontier between the work of the plumber and the work of the septic installer. So what our excavator did is he takes the line inside the house and then puts a 45, and that's what you see out there. And then I'm just going to use a fitting to connect to that one. And then what we have here, it's a two-way clean out. And this is pretty cool. It's required by code. And the way it works is if you ever get a clog, you get a snake either on this side to go towards the house or on this side to go towards the sewer. Now, one interesting thing of these ones is they have to be this way because it's really deep. There are others that are shorter. It's a one piece, but it's only required when you don't have too much dirt on top. But here we have many feet. And then what we have here, it's a Y. And that's because if you remember, the plumbing system of the main house is completely independent from the plumbing system of what we call the tiny house. That's why this one has its own two-way clean out by code. And then it just comes here and connects to the septic tank. And that's it.
We've spent a couple hours at least laying out the plumbing and whatnot, figuring out how it's going to be. And now it's time to begin the excavation of the crushed rock. We will show you the design once it's all excavated, because it'll make life easier when it comes to the connections and whatnot. Our excavator finished filling the hole for the foundation, and check that out. I don't know if you can see, it looks amazing. The turnaround around the carport and that kind of stuff. So this is where the cars will park. Check this out. Even the cars are gonna have a nice view. Let's take a quick walk over. Down here you can also see how he took care now of filling the septic tanks and all that stuff. So super exciting. And he also dug the hole for the foundation of the sheds. Finally, what you see here is the outdoors kitchen area. And this is most likely where we'll have a grill and we'll have all the friends that know us and come over and party. All the people that have helped us build this house will also come at some point in time, I'm hoping. So super exciting. And now we just kind of need to keep moving on the plumbing so that we can pass inspection as soon as possible. So we have a special guest today, my manager from work, from the real work, not this work. So he came to help us shovel some snow. And now it's lunchtime. If you've ever seen Guga Foods, you'll know it doesn't go that good right now, but watch this. Nice. Food is ready.
Our construction truck is awesome. We're saving probably $40 per tank versus a regular construction truck. And look at what it's capable of doing. Today we brought 5 10-foot-long PVC pipes to keep working on the plumbing. And we can even close the trunk. Isn't that nice? So let's keep working. Here we are doing the underground plumbing. And what you see right there, it's the fitting that it's collecting the drain from the upper floors. And this is the building drain. So this one will come this way, then it's going to turn and will eventually make it out to the sewer line. But first it needs to collect this bathroom, which is pretty complex. So let me show you what we have. So we have a vanity that starts over here. The drain is going to go through the wall and it's going to connect over there, and there will be a clean out. And that becomes a wet vent. So the wet vent is going to run that way. And then on that corner, we have the tub. And then it continues here, and here we have like a super highway of poop. Look at this. We have 2 levels of pipes. So well, we have the top there. It continues here. This one needs a clean out because I'm making too many turns. And then this one here is the shower. It connects also to the wet vent. Here we turn, and the interesting thing is that my wet vent ends right there because that's the kitchen sink coming from the upper floor. This one is a clean out for the toilet. This one is a vent for the toilet. Then this one here is the toilet itself. And then it's going to make a 45, connect to the building drain, and then go out to the sewer. So let's talk about wet vents. I love wet vents. They were a lifesaver for this complex bathroom. So first let's describe a regular vent. It's a pipe that goes all the way out to the roof, and it's going to bring air into all the fixtures that you have. The wet vent, the difference is that you have that pipe that is going all the way to the roof. The moment you connect the fixture and it has water, it becomes a wet vent, and it's allowed for bathroom groups. So the idea is, imagine that this is your pipe. If you use the toilet, wash your hands, and take a shower, all the 3 at the same time, this pipe is going to be full. But you're not expected to do all 3 simultaneously, right? So the idea is that since you're using only one, there's going to be water maybe just through half of it, and then the other half is full of air, and it's going to go to all the fixtures in the group. So in my bathroom group, my wet vent starts right here. I have a vanity about 4 feet that way that comes this way, and the moment it makes a connection and it goes down, that's where my wet vent starts. And here is why I love the wet vent so much. This is our bathtub, and the problem with venting individual fixtures is that when you connect the air, the vent, it has to be 6 inches above floor level. So in this case, if you have the bathtub and let's say you have the drain right here, the connection has to be up here. You cannot make an horizontal turn before then. So if you don't have any walls around it, you are in big trouble. So that's where the wet vent comes to save my life, because I have the wet vent right here and I have the option to connect my tub. Now, the important thing you need to know is that there is a limit on the length between the trap and the wet vent. It depends on the pipe size. In my case, I'm using 2 inch, so I can go up to 60 inches before I connect to the wet vent. Now, let me show you one of the cleanouts. So right here I have my wet vent. It's making a 90-degree turn. Then it's coming this way. Here I have another 45, and then I have a 45, so I'm making 180-degree turns. The rule is that if you make more than 135-degree turns, then you need to have a clean out. So that's why I have one here, where I have my superhighway of poop. This clean out is going to serve those connections. Continuing on clean outs, this is a clean out for the toilet, and this is the drain from the kitchen. So why do I have another clean out here? Well, I have a 90-degree turn and another 90-degree turn. That's why I need this one. And then this one here, it doesn't have a clean out. What's that? Why is that? Well, because it's coming from a vertical. You only need the clean outs when you have 135-degree turns horizontally. So this one has its clean out on the upper floor. This one here is the vent for the toilet. The toilet is right here. So you might say, like, well, you're having a wet vent. Why do you have another vent here? Well, remember that I connected the kitchen. The moment you connect a fixture that is not part of the bathroom group, that's where your wet vent ends, and you need to vent the next fixture on its own. And finally, after all this crazy circuit, our bathroom connects to the building drain, and it's going to come this way and out to the sewer. But first I need to show you this device. It's super cool. So come, let me show you. It's called a backwater prevention valve. And what it does is you have your drain coming this way. It's always open. This is a cool model. But if there's ever some nastiness and there's a blockage on the tank and then you have water coming the other way, then this flap is going to lift and it's going to close, and the water pressure is going to keep it in place. And that's it. It's important to note these ones need to be, whenever you have fixtures on a basement level, you need to have one of these. So for example, on the other house, we don't have it because the bathroom is 1 floor above the basement. And finally, let's talk about some best practices. So for any fixtures like sinks and vanities and showers, you are required to have like 1.5 pipe or 1.25 in some cases. Go with 2 inches. This guarantees that you don't have any blockages. Also for toilets, you are required to have 3-inch pipe per toilet. If you can use 4, it also helps avoid blockages. And the building drain, you can have 3-inch pipe if you have up to 2 toilets. The moment you have 3, you need to level up to 4-inch pipe. But if you can have 4-inch pipe for the building drain, that also prevents blockages. Another tip is for the toilet, don't put it as the last fixture, because if something is getting stuck, there's nothing coming after it. It's always good to have at least one other fixture that is going to connect to the toilet and help flush out anything that you have in there. So our plumbing is finally done, but we have one issue. So that pipe over there seems to be much higher than it should be. So what I'm going to do now is I'm going to use the laser to see how many inches above ground we have that. So this is a very frustrated Marcella. So here's what happened. That pipe that I showed you, I did the test bringing a 2-inch pipe and see if that would fix my problem. I remeasured with the laser and I have a bigger problem. So we need to bring that height down by about 2.5 inches, and if I just change the pipe, we're going down only 1 inch, so we still have a problem. So that was my best case scenario, and it's not going to work. So all this beautiful plumbing system that took me a good 6 days of full-time work, I'm going to destroy it at about